We move on to learn about the energy and intensity of sound waves. From this example of the tuning fork, we can see that there is energy being imparted on the air molecules here, and therefore we may define the intensity as the power per unit area, and the power can be derived from the energy per unit time, delta E divided by delta T. This is the power. We divide this by the area in order to get the intensity. The unit for the intensity is watt per square meter. Watt is the unit for power, and square meter is the unit for area. So in general, the intensity can be calculated from the power per unit area. The threshold of hearing is 1 by 10 to the minus 12 watt per square meter. So any intensity greater than this intensity can trigger hearing in our ears, in our brains, and we can recognize it. If the intensity is less than this value, then we will not be able to hear a sound. On the other hand, if the intensity is high, like 1 watt per square meter, this is the threshold of pain. Okay? That can cause pain to our ears, and it can damage our ears. So there is a range of intensities through which we can hear sound without problems. The range extends between the threshold of hearing, 10 to the minus 12, and the threshold of pain. We may convert the intensity in terms of the pressure. So the threshold of hearing corresponds to about 3 by 10 to the minus 5 Pascal over the atmospheric pressure, which is 1 by 10 to the power 5 Pascal. So the ear, the human ear, can detect variations in pressures with an accuracy or a resolution of 3 parts in 10 to the power 10. This corresponds to maximum displacement of air molecules, if we estimate that, of 1 by 10 to the minus 11 meter. Remember that the diameter of a molecule is about 1 by 10 to the minus 10 meter. So it's of the order of magnitude of the size of the molecule. For the threshold of pain, it's 29 Pascal over the atmospheric pressure. This corresponds to maximum displacement of air molecules of 1 by 10 to the minus 5 meters. Usually, we use the decibel scale when we talk about intensity of sounds. We define the intensity in decibel by this formula. It is 10 multiplied by the logarithm of the ratio I divided by I naught. I naught is the threshold of hearing, 1 by 10 to the minus 12 watt per square meter, and I is the intensity of sound. This is the scale used by the technicians in big theaters when they check on the quality of sound to make sure that all spots in the theater have acceptable level of sound, acceptable intensity. For a threshold of hearing, 10 log I naught divided by I naught, so it is logarithm of 1. Logarithm of 1 is 0. So the threshold of hearing corresponds to 0 decibel. If the intensity is 1 by 10 to the minus 11, then divide this by the threshold of hearing. You have 10 log 10. Log 10 is 1. Logarithm of 10 is 1. So this becomes 10 decibels. Then another example, if you take intensity 1 by 10 to the minus 10, divide this by the threshold of hearing, you have 10 logarithm 100. 100 means 10 to the power 2. Logarithm of 10 to the power 2 is 2 multiplied by 10, so it is 20 decibels. Threshold of pain, 1 divided by 1 by 10 to the minus 12, this is 10 to the power 12. Logarithm of 10 to the power 12 is 12 multiplied by 10, this is 120 decibel. So using the decibel scale, which is a logarithmic scale, it is now easier to deal with the variation in intensities. You are talking variations from 0 decibel to 120 decibels, rather than from 1 by 10 to the minus 12 to 1 watt per square meter. Usually, to protect our ears, it is good practice to wear earplugs whenever the sound intensity is about 90 decibel. That would be a good practice for the health of our ears. In this table, we see the intensities for some common sounds, like nearby jet airplane, 150 decibels, jackhammer machine, machine gun or jackhammer, both of them, 130 decibels, siren or rocket concert, 120 decibels, subway, power mowing machine, 100 decibels, busy traffic, 80 decibels, vacuum cleaner, 70 decibels, normal conversation, 50 decibels, mosquito buzzing, 40 decibels, whispering, 30 decibels, rustling leaves, 10 decibels, and the threshold of hearing is 0 decibel. So here, just to get an idea about this new scale, we use the decibel to measure the intensity of sound, to check on the noise pollution. Recent studies suggested that because of noise pollution in large cities, this play a factor. This contributes to the factors that cause high blood pressure, anxiety, and nervousness. And based on these studies, the federal OSHA regulations suggest that no office or factory worker can be exposed to noise levels that average more than 85 decibels over an 8-hour work day. So we need to be educated regarding the intensity of sound to protect our ears and to be able to assess various sources of sound around us. Sound waves in air are spherical waves that starts from the source and propagates in all directions, as you can see in this image. And the intensity can be calculated at any point. It is the average power divided by the area. The area for a spherical surface is 4 pi r squared. R is the radius. So you need to divide the average power by this area. If you consider another surface with another radius like R2 here, then the intensity at the surface here, defined by the radius R2, I2 is P average again divided by 4 pi R2 squared. Since the power is the same but the area is changing, so you can simplify, divide I1 by I2. This is the same ratio as R2 divided by R1, both are squared. So this gives us an idea how the intensity changes as we move away from the source of sound. As you move away from the source of sound, the radius gets bigger and bigger. The radius of the spherical wave gets bigger and bigger. As you can see, the wavefront gets less curved. If we keep increasing the distance, at one point we may treat the waves as plane surfaces. We call them plane waves.